Okay, starting with example 16-8, a rigid body mechanism is being shown to you on the right-hand side of this slide. First of all, can you identify the total number of rigid bodies which are in motion in this figure?
सर 2 beams joint से जुड़े हुए.
Any other
Sir,
thing
3.
which you can identify moving?
Yes, sir, collar भी है.
Sir,
So collar भी है. So overall, if we take a look at this figure, we have 3 rigid bodies which are in motion. The first one is the collar, which is constrained to move on this guide rod along the vertical axis. Then we have 2 rigid links. One is rigid link AB, which is being grounded from point A. So AB चूंकि हमने ground किया हुआ है, which type of motion is possible in link AB?
Rotational motion.
So since one point of link AB is being fixed, that is point A, so this rigid body is in pure rotational motion with respect to point A. What about link CB?
Sir, general motion.
Since अगर आप इस figure को देखें, at one instant this is the position of link CB. At the very next instant, when this collar has moved downward, this is the position of link CB. It means that this rigid link CB has undergone translation as well as rotation, that is general plane motion. Okay, so link CB आपका general plane motion में आ गया. It means that you have overall 3 rigid links. One is in translation, that is collar C. One is in rotation, that is link AB, and the third one is in general plane motion, which is link CB. So 3 links हैं, एक translation, एक rotation और एक general plane motion में. Is the motion clear to all of you?
Yes, sir.
Yes, sir.
Okay, now reading the statement of this example, we have a collar C which is moving downward at a speed of 2 meters per second at the instant shown. We need to determine the angular velocities of the other 2 links, that is link CB as well as link AB. Okay, so in order to perform the analysis of this collar, हमेशा हम जब भी velocity acceleration analysis करते हैं तो we are going to start from that link जिसका motion हमें known होता है. So since in this link the motion of collar C is known to us, so we are going to start from collar C. The collar C is constrained to move along the vertical axis downward. So what is going to be this vector VC if we are using the conventional XY coordinate system? So what should be this vector VC?
Minus J hat.
So it is going to be minus 2j meters per second, where 2 is its magnitude, and since its motion is directed towards the negative y-axis, so if you want to write it in vector form, you are going to include minus j vector, unit vector. So the complete vector would become vc vector equal to minus 2j meters per second. Okay, now moving on to our next link, which is link CB. So in order to perform the analysis of this link CB, since we have discussed earlier that this link is in general plane motion. So once this link is in general plane motion, it means that we are going to apply the relative velocity equation on this link. What should be our base point, C or B?
C, sir.
Since the motion of point C is known to us, so we are going to make C as our base point. So accordingly, the relative velocity equation would become VB equal to VC plus omega cross r. Both of them are vector quantities. Here omega represents the angular velocity of this link CB, whereas r represents the relative position of B with respect to C. So the overall relative velocity equation would become VC equal to VB equal to VC plus omega CB cross r BC. Okay, now completing these vectors in this equation, since VC is given to us as minus 2j, so VC की जगह मैंने minus 2j put कर लिया. Moving on to omega, can you judge the direction of the angular velocity of link CB? जो दो positions आपको show की गई हैं, वो क्या represent कर रही हैं? This is going to be the direction of omega, isn't it? So it is counterclockwise. So in order to write this vector, you are going to write omega CB in vector form. So counter clockwise को कौन से vector से represent करते हैं?
Okay.
So it is going to be represented by this positive K. So we are going to write omega CB K cross RBC, which is the relative position of B with respect to C. So what is this vector R?
Sir, cos 45 minus cos 45 plus sin 45.
तो सबसे पहली बात तो ये कि ये लाई करता है कौन से कोऑर्डिनेट में? द फोर्थ कोऑर्डिनेट, सो इट शुड हैव पॉजिटिव x एंड नेगेटिव y.
Yes, sir.
ठीक है, अब बताइए 45 डिग्रीज आपने कैसे निकाला है?
Sir, tangent से tangent y
सर पॉइंट टू सेम है.
तो y
यस सर,
देखिए
बेस और
एक तरीका ये पहले
परपेंडिकुलर
आप
0.2 है.
हाँ नहीं देखें, मैं यही समझाने की कोशिश करूं, ऑल्दो दोनों मेथड सही है, लेकिन एक तरीका क्या है कि 0.2 गिवन है, पहले आप उनसे 45 निकालें, फिर cos 45 sin 45 करके दोबारा उन 0.2 पे वापस आएं, तो अपने कोई 1-1.5 मिनट आप उसमें जाया कर चुके होंगे. डायरेक्टली आप इसको 0.2 की नहीं लिख लेते.
ये भी अच्छी बात.
So it is going to be 0.2 I minus 0.2 J. So this is going to be the relative position of B with respect to C. Is this point clear to all of you?
Yes sir.
Okay, so accordingly, if we expand it, it would be minus 2J plus taking the cross product. और आपको अगर determinant वाला तरीका ज़्यादा easy है तो आप वो use कर लें, मुझे ये ज़्यादा आसान लगता है. So first term is 0.2 omega CB. What is K cross I?
J है.
So it is going to be K. The second term is minus sign, चूंकि वो already मौजूद है, minus 0.2 omega CB. What is K cross J?
नेगेटिव I.
नेगेटिव I, तो नेगेटिव नेगेटिव प्लस हो जाएंगे और यहाँ हमारे पास ये क्रॉस प्रोडक्ट आ जाएगा, which is minus 2J plus 0.2 omega CBJ plus 0.2 omega CBI. So this would represent the velocity of point B, which is velocity B. ये point clear है रेक को?
Yes sir.
Okay, now moving on to our next link, which is link AB. So moving on to link AB, what is the type of motion which this link is undergoing?
Rotational motion.
Link AB is under rotational motion about point A. So for rotational motion, अगर मैं आपसे कहूँ link AB consider करें and we need to write what is going to be the velocity VB. So क्या हो जाएगा VB rotation के केस में?
r omega.
Vector form में बताएं.
Sir, omega cross r.
So omega cross R, but now here omega is going to be the angular velocity of this link, which is omega AB, and R is going to be the vector RB, which defines the absolute position of B with respect to A. So this is going to be omega cross R for link AB. As far as the vector form of this omega is concerned, अगर कॉलर नीचे की तरफ आ रहा है तो लिंक AB किस डायरेक्शन में मोशन कर रहा होगा?
Right side.
So this link AB would be traveling towards the right side. In other words, the angular velocity of this link is going to be in a counterclockwise direction. So omega AB vector can be written as omega AB K. Is it clear to all of you?
Yes, sir.
Yes sir.
Okay, what about this vector RB, the absolute position of B with respect to the ground A? What is this vector?
0.2 J. Negative 0.2 J.
Yeah, so this vector is being directed towards the negative y-axis. It has a magnitude of 0.2, so you can write it as minus 0.2 J. And again, expanding this determinant, expanding this cross product, it is going to be minus 0.2 omega AB. And what about K cross J? Minus I. तो ये minus minus plus हो जाएगा और आपके पास ये I बच जाएगा. So let me call it as my equation number 2. Now, equation 1 and equation 2 both represents the velocity of point B. एक में हमने with respect to length CB निकाली है और एक में with respect to length AB निकाली है. But since point B is a common point between those two lengths, connecting जो point है between those two lengths, so it should have same velocity, absolute velocity, same absolute velocity. It means that equation 1 and equation 2 can be equated, isn't it?
Yes, sir.
Yes, sir.
So equation 1 में मैं equation 2 से VB की वैल्यू अगर निकाल के डालूं, so that value would become 0.2 omega ABI. ठीक है? Okay, so now it is a vector equation. So what does this vector equation represent? It represents the individual I and j coefficients on both sides of the equation should be equal to each other. So once you compare the I coefficients on this in this equation, मैं top पे लिख रहा हूँ, अगर हम I coefficients को compare करें, so left side पे I का coefficient क्या है? It is 0.2 omega AB. ठीक है? So the I coefficient is 0.2 omega AB. So 0.2 omega AB जो है वो आपका coefficient आ गया right side पे. What is the I coefficient on the left side of this equation?
0.2 omega CB.
0.2 omega CB. What does this equation represents? Omega AB should be equal to omega CB. ऐसा ही है?
CB.
Yes, sir.
Okay, now comparing
Yes.
the J coefficients on both sides of this equation. So once you compare the J coefficient, what is the J coefficient on the left hand side of this equation?
0.
0. What is the J coefficient on the right hand side? It is -2 plus
Minus 2 plus
0.2 omega CB. So this is the equation for the J coefficient, 0 equal to -2 plus 0.2 omega CB. So these are the two equations which we need to solve it. So moving towards the final solution, ये आपके पास वो दो equations आई थी. I coefficients को compare करके 0.2 omega AB should be equal to 0.2 omega CB और J coefficients को जब आपने compare किया 0 should be equal to -2 plus 0.2 omega CB. So from this equation, omega CB comes out to be 10 radians per second. And since this omega comes out to be a positive quantity, it means that your assumed direction of omega was correct. Similarly, putting the value of omega in equation number 3 would give you omega AB to be equal to 10 radians per second again. And since again this value comes out to be a positive quantity, it means that at this instant both these links are in a are moving with a counterclockwise angular velocities of 10 radians per second. Is it clear to all of you?
Yes, sir.
ठीक है, कोई चीज जो आप पूछना चाहें,
Yes,
कोई क्वेरी, कोई
सर ये ओमेगा दोनों की सेम है, ये 45 एंगल की वजह से आया.
नहीं, वो जरूरी नहीं है. इस टाइम पे दोनों लिंक्स एंगुलरली एक्सेलरेट कर रहे हैं. वैल्यू सेम आई है, उसकी वजह क्या है कि 45 का एंगल है और लिंक की लेंथ भी बराबर है, लेकिन इस टाइम पे दोनों लिंक्स जो है वो काउंटर क्लॉकवाइज डायरेक्शन में मोशन कर रहे हैं. ठीक है, वो हमें वैसे भी नजर आ रहा है कि कॉलर जब नीचे जा रहा होगा तो ए बी ने तो हर हाल में काउंटर क्लॉकवाइज ही जाना है, सी बी भी जो है वो काउंटर क्लॉकवाइज ही जा रहा है. इसके मुकाबले में अगर मैं आपसे सिर्फ इतना चेंज कर देता कि दिस लिंक इज मूविंग, कॉलर सी इज नाउ मूविंग अपवर्ड. अब कॉलर सी अगर अपवर्ड मूव कर रहे हैं तो डेफिनेटली नेक्स्ट इंस्टेंट पे जो आपकी पोजीशन आएगी वो कुछ इस तरह की पोजीशन होती. इट मींस कि ये वाला लिंक भी इस तरफ जा रहा था, ये वाला लिंक भी इस तरफ जा रहा था. इट मींस कि दोनों ओमेगा फिर आपके जो है वो क्लॉकवाइज डायरेक्शन में आ जाते.